Hello everyone, myself Srivalli, working as an assistant professor in the Department of Data Science and Cybersecurity in MLR Institute of Technology. So today in this session, I am going to discuss about discrete mathematics subject. So before going to discuss about the statements and notations, connectives and truth tables, first let us understand what is the subject here, discrete mathematics. So first let us understand what is meant by mathematics. So mathematics, we already know that it is the heart of problem solving. It is a study of shapes, numbers, patterns and everything. So the word mathematics, it comes from the Greek word mathema. The meaning of the word mathema is science, knowledge or learning. So the whole world of mathematics is divided into two types. One is discrete mathematics and the other one is continuous mathematics. The whole world of mathematics is divided into two types. Here, discrete mathematics and next one is continuous mathematics. What is meant by this discrete mathematics? Discrete mathematics is a study of discrete objects and continuous mathematics is a study of continuous lines. So here let us take some examples to understand the differentiation between discrete mathematics and continuous mathematics. So here discrete mathematics, we can say that natural numbers are discrete in nature and continuous mathematics are real numbers in nature. So we can say that here natural numbers are discrete in nature and real numbers are continuous in nature. So what is this natural numbers? How we can say that it is example for discrete mathematics? So here basically natural number starts from 1, 2, 3, so on. And whereas here real number starts like 0, 1, 2, 3, so on. So here there is a sharp transition between 1 and 2. So that is called natural numbers where are discrete in nature. And coming to the real numbers here 0, 1, 2, 3, so on. So the relation between 0 and 1 we have number of numbers. Means between 0 and 1 we have number of numbers. Between 2 and 3 we have number of numbers. So that means they are continuous in nature. So that is why we are taking the example that real numbers are continuous in nature whereas natural numbers are discrete in nature. So this is the differentiation between discrete and continuous. Not only these natural numbers or real numbers, we can also consider digital clock and analog clock also the examples of discrete and continuous. So here digital clock is discrete in nature. There is a sharp transition from one time to another time, whereas analog clock is continuous in nature. Means here we have number of numbers between 0 and 1, 1 and 2, 2 and 3 like that. So that's why we are considering discrete is nothing but which is not connected. Discrete is the meaning of here which is not connected. So this is about discrete and continuous mathematics. And let us understand why we need to study this subject discrete mathematics. So here, if you study the discrete mathematics here, you can improve your problem solving ability. It will improve your mathematical thinking skills. And not only this, if you are going to study the subject here, so we can say that you are preparing for the GATE exams also. Means the subject is useful for the students who are preparing for the GATE exams, competitive exams, and the subject is useful to survive in other subjects like compiler design, automata theory, computer database security, so what not. The other all computer science subjects are useful for this discrete mathematics. So next we have, so let us understand here the overview of the presentation here. It includes statements and notations, connectives and also truth tables. So what is statement? So here first you need to understand what is meant by statement. A statement is also called as a proposition. So here what is the definition of the statement is a proposition is a declarative statement which is either true or false but not both. So here a proposition is a declarative statement. So declarative means here giving some information. So and that information must be either true or false. It can't be both here. So basically what is this true and false? So here these are called truth values. The truth values are nothing but here it can be either true or false. The truth or the falsity of a given proposition is called a truth value. And if that information is giving, then we can say that particular statement is called a proposition. A proposition is a declarative statement which must be true or false. It cannot be true and false. Either it can be a true or a false. So, we usually denote T with true, false F with here false. And these proposition variables are denoted by small p, small q, small or small s. Means we will be denoting these variables with the small letters, small alphabets. So, let us see some examples of the proposition. So, here first example is Paris is in France. So, here if you observe this is a statement first. Why? Because here this is giving some information. This is giving some information, whether it is a valid or not valid, it doesn't matter here. So, it is giving information first of all. And now, if this information is giving some truth value, so if you observe here, Paris is in France. Yes, it is in France. So, it is true. And next, London is in Denmark. So, here we know that London is not in Denmark. We are understanding that this is a false statement. But even though it is a false statement or a true statement, it is giving some information. So, that's why we are considering it as here. This is a statement here. Okay. So, next we have 1 plus 0 is equal to 1. So, we know that 1 plus 0 is equal to 1. Yes, that is what. So, this is giving true statement. So, we can say that this is a statement. And 0 plus 0 is equal to 2. So, here 0 plus 0 is not equal to 2. So, this is a false statement. 2 plus 3 is equal to 5. Yes, we know that 2 plus 3 is equal to 5. So, it is a true statement. And we know that 5 is a prime number. That's why it is called a true statement. So, if you observe these examples here, so here all the examples are giving some information to us, whether it is a true or false. So, that's why we are considering all are called propositions, or we can also call it as a statement. So, here you need to understand here proposition is also called as a statement. But what are not propositions? Let us see some examples of which are not propositions also. So, here if you observe, sit down. So, here this is not giving any information here. So, this is just, it is saying that sit down. And next we have what time is it? So, it is just asking, it is not giving any information here. X plus 1 is equal to 2. So, here we know, here we have 1 value, here we have x value and it is equal to 2. But here we can't decide that x plus 1 is equal to 2 until we know the value of x. So, as we don't know the value of x, we can't decide that x plus 1 is equal to 2. So, here we can't decide that whether it is a true statement or false statement. Next, here x plus y equal to z. So, here all our variables we have. So, we don't know what is x value, we don't know what is y, we don't know what is z. So, without knowing these values, we can't say that here x plus y is equal to z. So, here even we have 2 plus 3. So, what is 2 plus 3? We don't know what is 2 plus 3 here. Solve the equation here, 2 plus x is equal to 3 here. So, here even here also we don't know the x value. So, as we don't know the value of x here, so we can't decide that here 2 plus x is equal to 3. And even here 2 plus x is greater than 8. So, even here we don't know the value of x. So, if you observe all these examples, so here it is not giving any information. So, it is just saying that what time is it? So, sit down means we are not getting any information, and here from this we can decide that it is not a true statement or it is not a false statement. So, as we know that here these are not giving some information here, so we can say that these are not a propositions. So, here what is meant by a proposition is, a proposition is a declarative statement where it is giving some information and which can decide that whether it is a true statement or a false statement. So, then only we can say that this is called a proposition. So, next we have atomic statement and compound statement. So, here we can say that these are the two types of statements. So, where we have atomic statement and compound statement. So, first let us understand what is meant by atomic statement. So, here atomic statement is nothing but, in the name itself we have here, it is a single statement where it is represented with a single variable. And compound statement is called where it includes with more than one statement. Where it includes with more than one statement. So here a statement which is represented by a single variable is called an atomic statement, and a statement which is represented by two statements, that is more than one statement, is called compound statement. So first let us see here atomic statement how you will represent. For example, so let us suppose here we are considering one example here. Sun rises in the east. So this is one example here, and we can say that this is called a statement also. Why? Because it is true, as it is giving some information, and that information is also we are giving some truth value that is true. So this is called a statement. And now how you can represent the statement with the variable, and let us suppose here I am denoting with P. So P statement, sun rises in the east. So as we are representing with only a single statement variable, then this is called atomic statement. And coming to the next one, compound statement. So here compound statement is combining two or more statements using the connective. So here the same example here I am considering sun rises in the east and sun rises in the east and sun sets in the west. So if you observe this example, here we have one statement as sun rises in the east, which is stating as P, and sun sets in the west, which is stating it as here Q. So if you observe these two statements here, we are combining these two statements with the word connective. Means here we are combining the two statements. We can also combine two or more statements, but here we need one connective, which is called here we are using AND. So that is called compound statement. Combining two or more statements using some symbol, using some word is called compound statement. So here if you observe, here we got one new word which is called as connective. So basically what is meant by a connective? Let us understand here. So here connective is nothing but it can be a word or it can be a symbol which is used to combine two or more statements. And here basically we have 5 connectives in propositional logic. Generally we use 5 connectives which are negation, conjunction, disjunction, implication and biconditional. So here we have basically 5 connectives. Those are called negation, conjunction, disjunction, implication and biconditional. So let us see one by one here. Negation. So what is meant by a negation? So the other name for negation is not. We can also call this negation as a not. So what is this negation? The negative of a given statement is a negation. So it is denoted by the symbol negation. This is called tilde symbol. We usually call it as tilde symbol. So here if P is a statement, the negation of P, we can write it as negation P here. So suppose if you are having only one statement here, so the negation of that particular statement we will be writing as negation P. We'll read it as negation P, or we can also read it as not P. We can read it as not P. So let us see some theoretical example which includes negation here. So let us suppose here P is a statement where we have Peter has books. And what is the negation P is? Peter is not having books. Peter has no books. And Q, if you observe, Onida is a good company. And what is negation Q is? Onida is not a good company. So here what we are doing is in the negation, just the opposite of the given statement we are writing. So basically this negation will always is atomic statement, as we are dealing with only one operator and one variable. So this is called negation. Next we have truth table. So not only theoretical example, not only word examples, so we also construct the truth tables for all the connectives. So basically what is meant by truth table? A truth table is a mathematical table used to determine if a compound statement is true or false. So that is nothing but here we are constructing this mathematical table for the possible combinations of all the compound statements or atomic statements also. So in a truth table, each statement is typically represented by a letter or a variable. So here if you observe truth table for the negation, so here P we are representing with the variable here, and what is negation P here? So basically this P and negation P we used to denote with true and false. So the possible combinations for only one statement is either true or false. So here if you observe for the first statement true, if the P statement is true, the negation will become false. If the P statement is false, the negation P will become true. That is nothing but vice versa. If the P statement is a true, the negation of this P statement will become false. If the P statement is F, the negation of the statement will become true. So that is what we have here. In a truth table, each statement is typically represented by a letter or a variable like P, Q or etc. So as we have only one negation compound statement, atomic statement here, then we can write it as only here, only P variable. So here if you observe, that is like P, Q, R, and each statement also has its own corresponding column in the truth table and list all possible the truth values. So it will list all possible truth values here. So we have an only atomic statement here. So as we have atomic statement here, the possible combinations we have here is only true and false. So let us see the truth table for this. So here we have P statement and this is a negation P. So the possible combinations for this atomic statement is true and false. If P statement is true, the negation P will become false. If P statement is false, the negation P will become true. So this is a truth table for this negation here. Next we have conjunction. What is meant by conjunction? So here combining the two statements with the symbol or with the word connective is called conjunction. So here joining the two statements with the word and is called a conjunction. It is denoted by the symbol here and. So this symbolically we will be representing this conjunction as reverse V here and word is and. So suppose we have a P statement and we have a Q statement here. The conjunction of P and Q is denoted by P and Q. Symbolically we will write P and Q, or word we can write it as P, A and D and Q. So here if you observe the example, so P statement, let us suppose assume squares are rectangles here, and Q statement is here rectangles have 4 sides. So P and Q will become squares are rectangles and rectangles have 4 sides. So here what we are doing, just we are combining the two statements with the word connective and as we are including and here, this is called a conjunction. So let us see the truth table for this conjunction also. So here if you observe, as this is a conjunction, so we are applying between the two statements, that's why it is called a compound statement. So let us suppose P is a statement here, Q is another statement, and here we are writing P and Q. So what is this P and Q truth values? So before writing this truth values, first we need to write down the possible combinations for both the statements P and Q. So here true, 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 false, false, true and false, false are the possible combinations for the two compound statements here. And coming to the P and Q, so how we are getting this true, false, false and false? So here we have rule for each and every connective here. Suppose if this is a conjunction here, how we are getting all these values is, even if one statement is false, out of the two statements, even if one statement is false, the resultant truth value will become false statement. So here if you observe true, false, Out of this, one statement is false. That's why the resultant truth value has become false. And if for these two statements here, P statement is false. So that's why the resultant truth value has become false. And in the last row here, both the statements are false. So that's why the resultant truth value has become false here. And if you observe the first row here, as two statements are true and we don't have any false statement, that's why the resultant truth value will become true. So on the whole, conjunction means even if one statement is false out of the two statements, the resultant truth value will become false. Otherwise, it is true. So this is like how you have to construct the truth table for the conjunction. Next, we have disjunction. So here, what is meant by disjunction? So here, joining the two statements with or is called a disjunction. So previously in the conjunction, we have joined the two statements and we have used the word and. We have combined the two statements with the word connective and. And here we are combining the two statements with the word or. This is called a disjunction. And it is denoted by the symbol or. So which is nothing but V. Disjunction of P and Q. Suppose if you are taking P is a statement and Q is a statement, the disjunction of P and Q is denoted as P or Q. And if you see the example here, what example? Let us suppose we have two statements here, P and Q. So P statement is Anne is on the softball team and Q statement is Paul is on the football team. Now if you apply or for these two statements, then it will become Anne is on the softball team or, so here, or Paul is on the football team. So here we have combined this P and Q statements with the word or, with the word connective here or. So this is called a disjunction. Now let us see the truth table for the disjunction here. So here, just like the conjunction here, so we have considered two statements, P and Q statement. And here the same possible combinations you will get as you have only two statements here. So if you observe here, how we are getting these possible combinations is based upon the number of variables. So here, as we have two statements, so 2 power 2 is equal to total 4 possible combinations we will get. Suppose if you have three combinations, three statements here, three variables we have, so then you will get here total 8 possible combinations. So as we have considered here two variables, then you will get possible combinations are true, 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 false, false, true and false, false. Now, then how we get this last column resultant value for the disjunction? So here if you observe, so out of the two statements, even if one statement is true, then the resultant truth value is becoming true. Otherwise, it is false. So here if you observe, in the first row, both the statements are true, then the resultant truth value is becoming true. And in the second row here, if you observe, the second row, if P statement is true, the resultant truth value is becoming true. And in the third row, Q statement is becoming true and the resultant truth value is also becoming true. And if you observe in the last row here, as both the statements are false, as we don't have any true statement, then the resultant truth value will become false. So this is what a disjunction. Even if one statement is true, the resultant truth value will become true. Otherwise, it is false.